Hi, I'm Ken Collins. Welcome to my companion video to the engine swap series that I produced a couple years ago. Now in that series I put an Explorer 5 liter into this 88 turbo coupe. We went through the motor, we changed camshafts. It's not a very radical cam. It's what's called a speed density friendly cam, so I was allowed to retain the speed density stock Ford EC4 electronics. The stock injectors, 19-pound injectors. The engine, of course, does have the GT40P heads, and it does have the Explorer intake, which is an upgrade. However, I retained the 60mm stock Mustang GT throttle body. Now, the transmission is an AOD. It's actually the AOD that I used in my AOD repair video. It's just a stock overhaul with some upgrades, no modifications to the governor, so therefore when it shifts automatically, it shifts at a fairly low RPM. The rear end is a 373 gear, which is of course stock for the turbo coupe automatic cars. It does have a traction lock, and I have a pair of drag radials that fit the stock rims. Now, when I built this car, I built it as a 14-second car and on paper, which it did do that. I ran it a couple years ago, and it went 14:57 consistently in the middle of July with not very good air. I felt that with a little bit of tweaking, maybe manually shifting the 1-2, kind of changing tire pressure, maybe going to a slightly larger, maybe to the 65mm throttle body, I should be able to get it in the low 14s. And the idea behind that was the theme of the car was to run at the Fun Ford weekend shows in the True Street class. And in that class, you basically, you're escorted on a road trip, about 30 miles, 15 miles out, 15 miles back. Then you run the car 3 runs back to back. They take the average of the runs, and the car that's closest to a 15 flat, 14 flat, 13 flat, all the way down to an 8 flat at some tracks. There's not too many 8-second street cars, but there are a few. And you would win the closest average to those flat runs would win that particular class. And of course I was figuring to run the 14-second class. Unfortunately, after I built the car, the Fun Ford Weekend group went on hiatus for a couple years. It has been reinstated. There will be a Fun Ford Weekend show at a local drag strip here less than a month from now. However, they've abbreviated the program slightly. Instead of being 2 days, it's 1 day. And the True Street class now only has a 10 flat, 11 flat, 12 flat, and 13 flat class. Now obviously, even if I got close to a 14 flat, I wouldn't be competitive in the 13 flat class. Now I felt, well, I had decided that I may eventually do some upgrades to the car, maybe put a centrifugal supercharger on it. Certainly something more than a stock torque converter. The stock torque converter that's in this transmission is definitely holding the car back. But all of these modifications will be a little bit pricey, and there's a little bit of a time constraint situation that I'm dealing with, and to do these kind of upgrades and be able to test it in time, I don't think I really have enough time for that. So to try to get a second off the car just like it stands, there's really only one device that kind of fits that bill, and that is to install nitric oxide. All right, let me do a little explaining about what nitric oxide is all about. The designation of nitrous is N2O. In other words, there's 2 atoms of nitrogen and 1 atom of oxygen. So therefore, by weight, the gas is 36% oxygen. Now, the air that's around us is about 22% oxygen. So therefore, if you're able to take this substance and inject it into the intake and add a proportional amount of fuel to it, about a 10-to-1 ratio, you will be able to have much higher combustion. Now for a fuel injected car, there's basically two systems out there. You have a dry system and a wet system. If you happen to have a carbureted car, all of them are wet systems. But with a fuel injected car, they found that there is a way to inject the nitrous without having to add extra fuel lines. What is done is the pressure that's in the bottle is very high, and it's introduced to the top of the pressure regulator. When you add pressure to the top of the pressure regulator, you're putting pressure on the top of that diaphragm above atmospheric pressure. Therefore, it will artificially raise the fuel pressure. And generally, most of the EFI cars, at wide open throttle, you'll have about 40 pounds of pressure on the fuel rail. By introducing this extra pressure on top of that regulator, it will make it go to about 80 pounds per square inch. Obviously, when the injector opens, now a whole lot more fuel is going to go in. Just like your garden hose, if you just have your spigot on a little bit, you have a little bit of water, and then if you run the spigot wide open, you're going to have more water coming out of the hose. Essentially, that's what you're dealing with here. On a wet system, the nitrous and the fuel is introduced in the nozzle at the same time. So therefore, you have a separate solenoid that's hooked into the fuel rail. So now fuel pressure goes directly into that nozzle, and most of these systems that are a single nozzle system injected just ahead of the throttle body. So this way it's completely independent of your EFI system. Okay, what's the advantages and disadvantages of either system? Well, on a fairly stock engine, the dry system probably is really has more of an advantage. It's certainly less parts involved. You don't have any fuel lines that you have to hook up. Another thing that's kind of nice is that typically with a multi-port injected car, your intake plenum is not designed to have fuel in it. It's really designed only to have air. So therefore, since the injectors are doing all of the enrichment, you're going to have really nice fuel distribution because it's now injecting it right directly at that intake valve. And only the nitrous is going through the intake plenum. But of course there's some limits to it. You're only going to raise the fuel pressure up so high. If you get the pressure too high, you're going to overshoot the fuel pump, and the fuel pump won't be able to keep up. And there might even be a chance where the injectors would want to stick open because the pressure is so great it will hold the pintle off of its seat, and then you wind up having an overrich system. On a wet system, the advantage, of course, is that it's completely separate from your engine electronics and your fuel rails and your fuel injectors. So therefore, if you did some modifications and you went from a 19-pound injector to, say, a 30-pound injector, and maybe you did a lot of manipulation with, say, a programmed chip, and you're changing, the shot rate, this type of thing. Now you are kind of disturbing what is normal, and the dry system may not be able to compensate for that. The wet system, of course, being totally independent, would have no change whatsoever. It would still be shooting that nitrous and the fuel in at the correct ratio, regardless of the modifications that you've done to your injector system. For this project, I decided to go with a wet system. And of course, it's a single nozzle system to keep it simple. And the nozzle will be mounted somewhere close to the throttle body. Let's take a look at the table and I'll show you some of the parts. Of course, here's the bottle. It's a 10-pound bottle, which is standard on most of these kits. Here's the brackets that will go in the trunk to hold the bottle in place. Here's the solenoid pack. This particular brand has the fuel and the nitrous solenoid in a single little box here. Here's the toggle switch that's used to activate it. Some wiring hardware here and some extra wires. This is the little switch cover here. It's used to cover the switch to keep it from accidentally being armed when you're not ready. Here's some hardware, the little jets that go in the nozzle. Here are some little adapters that go on the fuel rail. Again, of course, here's the nozzle. This has two inlets. You have one for fuel and one for nitrous. If it was a dry system, of course, you would only have the inlet for the nitrous. And here's some the fuel lines, and here's, of course, the real long nitrous line that will go from the trunk to the engine compartment. And I also bought the optional purge system, which has its own solenoid, a little line, a little steel line here, some wires, and some extra hardware. Okay, before we get into the installation of the project, there's a few things I should go over. Most of the companies that make these single nozzle systems build their system to work well with a stock engine. And that's true, but there's a few things you should do to the car to get the best performance and to build in a certain margin of safety, and that is to prevent detonation. First thing, use premium fuel. Use 93 octane. If you have that in your area, use nothing lower than 91 octane, and frankly, if that's the best you can get, I would get one of those additives that you can put in the fuel tank to raise the octane level. Next, make sure your fuel system is up to the task. When you're running nitrous, you're going to have to run a lot more fuel when the system opens up. And most of the stock fuel pumps that's in the E4 cars, in the case of a GT Mustang with a 5-liter, has I think an 88 liter per hour pump. It's probably okay on a stock engine, but it's marginal for anything else, like if you're supercharging or turbocharging or putting nitric oxide on. In my case, I had to put a fuel pump in it anyway. I think because the car had been sitting a long time, it got corroded, and the fuel pressure would never really build up. So I went ahead and bought a 255 liter per hour pump, which I believe is about the maximum volume pump that will go in the stock fuel tank. Next, if you have one of those power chips, or you've reprogrammed your processor, which normally means in a normally aspirated car, you're running higher ignition timing and maybe a faster advance, where the advance comes up at a lower RPM. You definitely don't want that with nitrous. You should go back to more of a stock tune. And not only that, generally your ignition timing, base timing, is 10 degrees before top dead center when you take that little spout wire out. I would say, just to give you a little bit more safety factor, go ahead and bring it back to maybe 8 degrees before top dead center. And again, use more of a stock tune insofar as your ignition timing is concerned. Lastly, you should consider your spark plugs. The stock spark plugs are usually okay if you're running the lowest shot rate. You may have an adjustable system where you can run, 75, 100, 125 shot. If you're running the lowest shot rate, the stock spark plugs may work fine. Anything more than that, you should consider going down in a heat range and use a non-platinum style spark plug. Use a copper coated type spark plug, and also the racing style spark plugs that have the shorter ground electrode. That's a good idea too. I understand that some of the extended electrodes that's used on many of the stock style spark plugs, which is good for emissions and low speed performance, can cause a problem because they will tend to overheat, glow, and that can cause detonation. So the performance type spark plugs and going down in a heat range is probably a good idea. All right, right about now, if you've watched some other videos, you would typically see a table full of tools to show you all that's needed to do, that project. In the case of this nitrous project, frankly, all you need is just normal hand tools. You do need a drill motor and some drill bits. You need a couple large bits too, 1/2 inch, 9/16. You need a test light. If you have a digital voltometer, that's good. And you will need some pipe sealant, and you really need the liquid version of pipe sealant. We're all familiar with the Teflon tape, the tape to go around the threads, to put fittings in or two pipes together. But on a nitrous system, you do not want to use the Teflon tape. There's always a risk that a little sliver of that tape could slough off, get down that nitrous line, and when it makes it to the nozzle, if you look closely at these nozzles, it has a very, very small orifice. A little piece of trash or a little bit of that Teflon tape gets up into that orifice, and you're going to have, all kinds of problems. Another thing I really want to stress, we are dealing with high pressures. A nitrous bottle that's fully charged may have 1,000 pounds per square inch of pressure on it. Electronic fuel injection, you have high pressure on the fuel line, and we will be dealing with fuel lines here. So use some common sense, wear safety glasses while you're doing this project. I would say go a step further. Be sure you have a working fire extinguisher somewhere close by as well. It's only as dangerous as if you're unprepared. So as long as you're prepared, you take your time, you should be fine. But wear your safety glasses. Now off camera, I did a couple things just to speed the video up, and that is right off you need to determine two things. Where are you going to mount the nitrous bottle, and where are you going to mount the solenoid pack? All right, for the nitrous bottle, obviously you would typically want to put it in the trunk, but you can't just start drilling holes helter-skelter, because you will go right through the fuel tank. In my case, I found a good place to mount it, and you typically want to mount it on the right-hand side. More ballast on the right-hand side is better in a drag race application. But in my case, I wound up being right where the frame rail is. So I actually had to measure carefully and make sure that my bracket straddled the frame rail. So I have one bolt on one side and one bolt on the other. And of course, there's two brackets. Now in the case of the solenoid pack, you should figure, well, anywhere if you put it on that right-hand fender well area, you would be fine. But think about it for a second. You have a bunch of these lines that came with the kit, and they're usually pre-cut. And they have to go from the solenoid to the nozzle on the output side. And on the input side, of course, you have the line coming from your tank, from your nitrous tank, and from your fuel line. So you need to mount it in such a way that you can service it very easily, but that all your hoses will reach without putting a big kink in it or stretching it like a banjo string. So let's go back to the trunk first. I'll show you what I did in that area, and then we'll start looking under the hood. Okay, you see the two brackets are in place. The front bracket is the one that sets up, because that's the way you want to orient the bottle. You want the cutoff valve and the nozzle to be facing toward the front of the car, and you also want that part of the bottle to be setting up just a little bit. Now, this instruction kit did not give me a template to tell me how far apart these brackets went. I just simply mounted it on the bottle and determined that I found that about 9 1/4 inches between the front and the rear bolt seemed to be pretty good. I also, as I said before, I checked and I could not mount it down here low because it's too close to the fuel tank. Up here seemed to be ideal, but you had the frame rail that was in the way. So I carefully measured to make sure that the inboard bolt and the outboard bolt straddled that frame rail. Seemed to work out okay. You also notice that I have the nitrous line already mounted. I actually have it going on the inside of the car. Now normally you would have it running on the outside of the car, somewhere next to the pinch weld or along where the fuel lines are. And the main thing you want to determine when you're mounting it under the car is that it's not in the way of any rear suspension parts, and it's not too close to a tire or too close to the exhaust system, that type of thing. But because this is such a long wheelbase car, I felt that I only had so much line, so the straightest shot between here and the front would be on the inside of the car. So I've actually run it behind the seat. I had to take the rear seats out, and it's between the seat and the right-hand C-pillar. We'll go on the inside and take a look at where it comes out at. You can see where I have it coming down the right-hand side of the rear seat, then down to the floor area, then across the door opening on the right-hand side, and I'll simply have the scuff plate covering the hose in that area. Then going through the kick pad area, and I found a hole in the bulkhead near the door hinge to have the hose go out into the outside of the car, then over top of the inner fender on the right hand side, and I also found a hole near the radiator support where I have the hose coming back out into the engine compartment. Okay, you can see where I've mounted the solenoid pack. Again, I've put it in a convenient area. It's real easy to service. The position allows me to run, the nitrous line right to this outer fitting, no problem. The fuel line, which will come off of here and then go to my Schrader valve, which is right in this position. And remember that when I did this project, I used the Crown Victoria fuel rail, which has a remotely mounted Schrader valve. Most of the Mustangs would have the Schrader valve right on the fuel rail itself. Either way, there's enough line length to accommodate that, and the kit came with several adapters, so I can take this Schrader valve fitting out and actually put a pipe fitting with a -4 AN fitting on the other end, which is compatible with the hose that's going on there. Now the output side, here's one of the hoses, and I found that I can easily run the hose around right here like that, and this is where I'm going to mount the nozzle. In fact, I've already mounted the nozzle. I'll show it to you. Here it is on the inlet tube. I've mounted it right here in the bend. You remember this goes, right on the throttle body right here, and the hose easily goes around the curve and will mate up to the nozzle. And of course, I'll have a fuel line and a nitrous line going to it. Now to make this connection, there was a bung that came with the kit. I had to drill a 9/16 hole in the tube and then put this a bung which has a nut on the outside of it, and it's threaded so I can put the nozzle in. And you have to watch and make sure the nozzle is oriented right so that the spray sprays in the right direction. It needs to spray, of course, toward the throttle body. Now the kit says that the nozzle needs to be mounted between 6 and 18 inches away from the throttle body. I think having it in this bend it's probably about 6 inches, so I should be fine there. Okay, I also have a purge solenoid that has to be mounted. I think I'm going to put it across the front of the shock tower area here. I'll be able to run the adapter hose that will come from the nitrous inlet side and then come around to a fitting. I think I'll mount it this way and have it come in here. Then I'll use a 90-degree fitting on this side, and I'll run a steel tube. I'll have to use a longer one than came in the kit, and have it run across the top of the shock tower and then out kind of where the right-hand windshield wiper blade is. Okay, let's get started on the installation. Back here in the trunk, I like to take my air blower and blow down this nitrous line just to make sure, because when you string these lines in under the car or even inside the car like I did on this one, you might get a little trash or something in the line. So let's make sure it's good and clear. All right, and we'll go ahead and thread it to the bottle here. Tighten her up. And position the bottle so that the nozzle faces down. We want that facing down like that. And I'll go ahead and clamp the bottle into position. All right, let's go to the front. Okay, now I'll install the nitrous line, and remember we've added a purge solenoid. It's already mounted on the fender, so therefore I have to put this adapter hose on. So we'll thread it into the fitting, and remember these fittings on the solenoid pack are labeled. This is a -4 AN fitting. Now I'll take the other end of the adapter hose and put it on the purge solenoid, and this is a -3 AN fitting. Now I'll hook the input fuel line up, but I won't mount it to the fuel rail just yet. Now I'll put the nitrous and fuel output lines on the solenoid, and these are -3 fittings. And I made sure these lines were blown out as well. And I put a little hose clamp here, and we'll screw it to the fender area just to kind of clean up the installation a little bit. Alright, I've already bent the steel line that I'm going to use as the exit tube for the purge solenoid, and I've got a little bracket that's going to go up here. I need to drill a hole in the cowl. I'll do that a little later. Okay, there's still some plumbing left to do, but we'll stop here and do the wiring. The wiring is pretty straightforward on this project. The controller has 3 wires on it. One's the ground, one is the activation wire that will go into the passenger compartment, and it needs to be on a 12-volt switched circuit. So in other words, it only has 12 volts when the switch is on or when the engine is running. And these solenoids can draw as much as 10 amps. So therefore, the circuit that you use needs to be able to have a 10 amp load. It should be on a circuit that already has a 15 or 20 amp fuse in it. The third wire goes to the signal wire of the throttle position sensor. Alright, I also have a purge solenoid. It has 2 wires. One will be ground, and the other one, of course, is the hot wire that will go into the passenger compartment to its switch, so when I push the switch, it will purge the system. So now let's go ahead and start wiring this thing up. Okay, the 2 grounds I'll put right here. Okay, now I'll take the white wire from the controller, and this goes to the signal wire of the throttle position sensor. Now on this throttle position sensor you have 3 colored wires here, an orange, a green, and a black. And it's the green wire is the one we want to tap into. But I'm not going to tap in on the sensor end. I'm going to tap in on the harness end. So I'll follow the green wire down and see where it goes, and that's where I'm going to tap in. Now the kit comes with a little splice piece. I'm going to solder it into position, and then I'll use a male-female end on the wire end so I can unplug it if I ever need to take the controller off. Okay, now I'll take the last 2 hot wires, one from the controller and one from the purge solenoid, and fish it through a grommet that's already in the firewall, and of course those will go to switches in the passenger compartment. Now I'll go ahead and put male-female fittings on these wires as well. Again, in case I need to service either solenoid, I can simply unplug it and not disturb the wires that's in the passenger compartment. Okay, I've labeled the wires going into the passenger compartment, plus I've staggered the male-female ends on the solenoid end. That way I won't accidentally plug the wrong wires together. And then I'll take a couple wire ties and put these wires against some of the looms that are already under the hood. And then we'll go into the passenger compartment. Okay, I found a 20 amp circuit that's switched, and I've soldered in a couple pigtails. Then I have my momentary switch for the purge solenoid. It's hooked into that pigtail, and the other wire simply goes out to the wire that goes under the hood. And my arming switch the same way. One wire is going to the pigtail that I soldered on that circuit, and the other wire goes out to the wires that go under the hood to the controller. Now I can make one test right now. I can turn the key on and I can verify that the purge solenoid is electrically connected. So let me turn the key on and then I'll push the button in. You should be able to hear the solenoid click. That lets me know that electrically the purge solenoid is connected. The next thing I need to do is turn on the arming switch, then go under the hood, and I have to go through a training session for the controller. We'll do that now. Okay, to train the controller, I need to turn the key on and flip the arming switch to the on position, which I've already done that. And the instruction sheet tells me to push the button in and release it one time. It's right here. Pushed it in, released it. Said the red light should be on. Actually, it was on even before I did that. That's letting me know that it's in the activation learning mode. The next thing it tells me to do is to put the throttle to the wide open throttle position and hold it there for 10 seconds. So I'll do that. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I'll let go of it. And it says release the throttle pedal and go back to the unit and observe the light. And it says that it should flash red, green to off, which it's doing that. And then it says this way it lets you know that it has successfully learned the curve. Now it says to go back and turn off the arming switch and then turn it back on. So we'll do that. All right, I've turned it off and turned it back on. Now I see that the light is green and it's staying green. All right, the instruction says that at this point, if it's a solid green light, that lets you know that everything is set correctly. Then it says you can go ahead and push the throttle all the way to the full position or wide open throttle position, and we should hear the click of the solenoid. So let's see if that happens. There you go, you hear it click. I'll go back to idle, then push it again, and you hear it click. Okay, looks like that it's fully learned. Very good. Okay, I've turned the key off, disarmed everything. Now it's time to finish doing the plumbing. What I'm going to do is hook the fuel line in. I'm going to go into this where the Schrader valve is. I'll remove it. Remember, there'll be fuel pressure on it, so I need to wrap a rag around it, put my safety glasses on, get that fitting off, then wipe off all of the fuel. Then I have to put this adapter that came in the kit into that hole. And remember, I'll have to use some of that liquid thread sealant on the threads. Put it in the fuel line. Then I have a 90-degree fitting that will go on to this, and then in turn my dash 4 fuel line will hook into that adapter. Then after I finish that, I'll turn the key back on, then make sure I don't have any fuel leaks, and I'll go to the next step. Key on, no fuel leaks. Looks good. Okay, we're almost at the end of the installation. Off camera, I did a few things. I put that little outlet tube onto the purge solenoid. I lowered the solenoid about a ½ inch. I found that it actually interfered with the air intake tube going to the throttle body. And also the 90-degree fitting that I put on the fuel line, I had to remove that and use the straight fitting, which allowed me to have a little bit better routing for the fuel line. Now essentially all I really need to do is to put the appropriate jets in the nozzle and screw on the outlet hoses and go racing. But before I do that, I'd like to do what I would call a wet test. Now I thought all I really needed to do was to arm the system, put a cup under the fuel line, and then when I go to wide open throttle, I should have fuel come out. Well, I tried that and actually nothing came out. Then I realized that this system is designed in such a way that nitrous pressure has to be present on that solenoid pack to allow fuel and nitrous to go through those solenoids. And the idea there is as bottle pressure drops, it also drops the fuel volume proportionally, so the air-fuel ratio will stay the same. And of course, if you have no bottle pressure, then no fuel goes through the solenoid. So I thought, well, if I took the nitrous hose and stuck it in the nozzle and did that, I could verify that the fuel is coming through, but then I would have an intake full of nitrous, and then when I went to try to restart the car, I would have a heck of a backfire. So I don't want to do that. I don't want to have the hose loose, because with 1,000 pounds per square inch on that bottle, that hose would frail around and hit the hood and the fender. It could actually be kind of dangerous. So what I decided to do is to make a little tool, and I'll show it to you now. What I have here is a few hardware store items. I have a ball valve here that gives you an off position and an on position. I have a 4-inch nipple on this side, and I have a -3AN fitting on this side. And what I'll do, I'll take the nitrous outlet line, screw onto this, tighten it down, then we'll start our wet test. First, I'll go back to the trunk and I'll turn the bottle valve on and then turn it off. That pressurizes the line going up to the solenoid pack. Then I'll turn the ignition on and arm the system. Now I'll put my tool onto the nitrous line, and remember, when you follow these lines down to the solenoid, they are labeled. Tighten that up. Make sure the ball valve is in the off position. Lay that aside. Now I'll take my paint mixing cup, put the fuel line down into it, have my safety glasses on, and now I'll move the throttle to the wide open position. There you go. Okay, that was only a little bit of fuel, but understand the fuel pump is not running. It was only the fuel pressure that was in the fuel rail at the time. It still tells me two things. It certainly tells me that the fuel solenoid did work, and it also tells me that nitrous pressure was available at the controller, which activated the system. Okay, if no fuel came out, cycle the switch and try it again. There's a chance there wasn't enough pressure in the fuel rail. Now I'll disable the system, hit the purge switch to release the pressure on the input side of the solenoid. 3, 2, 1. Okay, no pressure there. Actually, I heard it hissing a little earlier, so the little bit of pressure that was in the line has already leaked out. I'll go ahead and remove my tool, and then we'll go to the final step. Now, in testing a new system, I think you should go with the lowest setting first. And on this kit, a 75 shot is the lowest setting. And the chart tells me that the nitrous nozzle needs to have a number 40 jet, and the fuel needs to have a 26 jet. So we'll go ahead and install those. Put the lines on, and be sure you have the correct line on the correct nozzle fitting. And then tighten them down. And with that, we're essentially ready to go racing. And like I said earlier, I've already prepared the car. The tank is full of 93 octane fuel. I've already changed the spark plugs to the style that has the short electrode, and I will be setting the timing back to 8 degrees on the initial timing. I've also set the system up for a very conservative first run. The jets are installed to give me the 75 shot, which is the lowest setting for this system. In the first run, I'll likely roll out of the beams, 5 or 10 feet, and then hit it. So if the extra torque causes me to lose traction, I'll be able to let off the throttle and stay in control of the car. If it feels fine, I'll run it all the way out through first gear, on into second, maybe to the 8th mile mark. If there's any question about a problem, if I hear detonation, if it starts backfiring, if it's missing, I'll let off the throttle, get back to the pits, try to determine what's wrong, and then make a full pass. And remember, when you have a nitrous car, there's a procedure you go through. You want to have the system disarmed while you're doing your burnout, and then after the burnout, arm the system, and before you stage the car, hit your purge button once or twice. The deal is that eventually the nitrous that's in the line will change from a liquid to a gas. You want to get that gas out of there. By purging it, it will cause all of the nitrous to be in the line will be in its liquid state. That's what you want. Then when you make your pass, from one run to another, it'll be more consistent. Thank you very much for watching this companion video to my engine swap series. I hope it's given you some good information on installing your own nitrous system, and as always, good luck on your project.